Right, we've looked at quite a lot of the instructions in LMC so far, and I don't think we're going to have a look at any new ones now. So that is all the instructions you actually need to know for GCSE Computer Science in terms of LMC and assembly language. So what you need to know is what all of those instructions are and what they do. You might be given some code and you have to work out what the code does, or maybe they'll give you something and it doesn't quite do what you expect it to and how you would change it. You'll never be asked to actually write the code, you'll be given some code and you have to say what the code does. And maybe explain what each of the instructions does. Okay, so the last thing I'm going to do is actually apply this to mathematics. So a subject and a topic in GCSE Maths you will probably have covered if you're doing this currently in year 10 or year 11 is sequences. So in order to calculate the equation for a given sequence of numbers, we must first look at the difference between them. So we've got the index term. This is just telling me which number it is in my sequence. It's the first one, the second one, the third one, the fourth, fifth. So the first number is 3, the second number is 5, the third number is 7, the fourth number is 9, and the fifth number is 11. So it says we need to look at the difference between them. So between these numbers, what is the difference? Well, the difference between 3 and 5 is 2, the difference between 5 and 7 is also 2, and so on and so on. So they're all 2. So you can see the difference between these is 2. So the number in front of the nth term in our equation must be 2. So when we're talking about sequences, we usually write an equation which we call the nth term equation. So we'll have this value n, which is essentially the values above the numbers here. So where they appear in the sequence. First, second, third, fourth, fifth. And because the difference between the values in our actual sequence is plus 2 every time we add 2, then in front of the n we need to put 2, so it becomes 2n. And now we need to check if we need to add or subtract from 2n. If 2n was my equation, does it work? If I do 2 times 1, do I get 2? No, I get 3. 2 times 2 would give me 4, but the actual value is 5. 2 times 3 is 6, but the actual value is 7. So we actually see that I need to add 1 to this equation. 2 times 1 is 2, plus 1 would be 3. 2 times 2 is 4, plus 1 would be 5. So the actual equation should be 2n plus 1. That's just going to cover all of that there. So we need to add that 1 to correct it so that it actually gives us the correct value every time. So that sequence 3, 5, 7, 9, 11 up to infinity is given by the nth term equation 2n plus 1. And you can try that with any number. I could put in any value now for n, and I can work out what the value in the sequence would actually be, what the number in that sequence would be. If I wanted the 30th one, I could put 2 times 30, which is 60, plus 1, 61. So the 30th value in this sequence would be 61. Okay, so it's quite a powerful tool you can use in maths. Here's another example. So we've got the first 5 terms of a sequence of -3, -1, 1, 3, and 5. What is the difference between each term? So let's think about it. -3 to -1, I'm adding 2. -1 to 1, adding 2. So each time I'm adding 2 to it. So the equation then must be, like in the last example, if we're adding 2 each time, in front of our n, we're going to have 2n. Do we need to add or subtract something to get the right values? If I do 2n times 1, because this is the first value, 2 times 1 is obviously 2. But the actual value we want is -3. So the difference there is we need to take away 5. The second value, so 2 times 2 would be 4. That doesn't give me -1, so I need to take away 5 again. So you can see that we actually need to subtract 5 each time to get the correct value. So combining that with 2n, we've got 2n minus 5 is the nth term equation for this sequence here. Okay, so you guys have a go at actually answering these questions here. So the first question, you need to write out the nth term equation. and calculate the 20th term in the sequence for each of these 5 sequences. So you do 1A, 1B, 2A, 2B, and so on. Once you've answered those, question 6, A, write out the first 5 terms of the sequence given by 3n minus 7. And then B, calculate the 15th term of the sequence. Okay, so I'll give you some time to try those questions. So I'm going to try and do this on Word. So 1A, write out the nth term equation for this sequence here. So what is the difference between each one? 1A. Well, the difference between each number, 7, 8, 9, 10, 11, I'm just adding 1 each time. So in front of my n, I'm going to have 1n. But obviously, in maths, we don't have to write 1n, because we can just write n. So it's n. But if I'm just doing 1 times 1 gives me, well, 1. It doesn't give me 7. 1 times 2 gives me 2, not 8. So what do I need to add in order to get to that number? So from 1 to 7, I need to add 6. From 2 to 8, I need to add 6. From 3 to 9, I need to add 6. So the equation for this would be n plus 6. And then B, what we would get is the 20th term. So I need to, into this equation now, I need to, instead of having n, replace that with 20. So 20 plus 6 is 26. So the 20th term in the sequence n plus 6 would be 26. Question 2. So 2A, the sequence is 3, 6, 9, 12, 15. If I zoom in, oh. So what am I adding each time? Well, it's going up in 3. So I know that in front of the n, I need to have 3n. Do I need to change anything to it then? So 3 times 1, the first term, would be 3. That's exactly what I need. 3 times 2, the second term, would be 6. So actually, we don't need to add or subtract anything to 3n. That sequence is given by 3n, which is essentially the 3 times table. So then B, what do we need for B? Well, the 20th term again. So instead of n, I replace it with 20. So it's just 3 times 20, which is 60. Okay. 3A. 12 times, oh sorry, in between each one, so we've got 12, 17, 22, 27, and 32. So it's going up by 5 each time. So I know it's 5n. Do I need to add anything? So just look at the first number. 5 plus, what do I need to add to 5 to get to 12? I need to add 7. If I do 5 times 2, which would be 10, I need to add 7 to get to 17. So I add 7. 5n plus 7. B. So now I've got 5. I'll put this in brackets. 5 times 20 plus 7 equals, so 5 times 20, 100, 107. Yep, so double check that. My mental maths is not the best. 4, so minus 6, minus 2, it's going up in 4s. And if I did 1 times 4, so the first number, I need to actually take away 10, minus 10. Let's double check that. So if I did 4 times 2 would give me 8. I have to take away 10 to get to minus 2. 4 times 3 is 12. If I take away 10, that gives me 2. So, yeah, 4n minus 10. B, so I replace n with 20. 4 times 20 minus 10 equals. So 4 times 20 is 80. Minus 10, that gives me 70. Question 5a. Now this time the numbers aren't going up, they're going down. So what we have to do is the number in front of n is going to be whatever it's going down in. So let's see. It goes from 3 to minus 3, so it's going down by 6. So it's minus 6 n. Now if I do minus 6 times 1, that gives me minus 6. But I need to add something to that to get to 3, which is 9. Let's try it with 2. So minus 6 times 2 is minus 12. If I add 9 to that, it'll go up to minus 3. Yeah. Okay, and then B. So I put that into the formula. This time it's minus 6 times 20 plus 9. So minus 6 times 20 is minus 120. If I add 9 to that, it's going to go up to minus 111. So that's those answers. And then 6a. Write out the 5 terms of the sequence given by 3n minus 7. So the first 5 terms. So I need to put n is 1. So if n is 1, what is the formula going to be? 3 times 1 minus 7 is minus 4. If n is 2, 3 times 2 is 6, minus 7 is minus 1. And you can see, because it's 3n, these are going up in 3s, so I don't actually have to do that calculation every time. I'm pretty confident I can just keep adding 3. So 2, 5, and 8 are the first 5 terms. And then B. Oops, what happened there? I don't know what's going on there. Let's scroll back all the way down to the end now. Okay, made it back. Calculate the 15th term of the sequence. So B is, we just need to put in to the formula 3n minus 7, 15. So 3 times 15 minus 7 equals 45. Take away 7, it's 38. And that's the answer to the questions. Okay. Now, what does this have to do with LMC? So we can actually write a program which generates sequences in LMC. It's not an easy program to make. It's not as complicated as the multiplication challenge, I don't think, but it is similar to it. So we're going to implement this nth term equation in LMC to produce the first 5 terms in a sequence 5, 6, 7, 8, 9. So I want the output to look like it does on the slide here, 5, 6, 7, 8, 9. So you can have a think about how you would actually do that. So some tips here. What is the nth term equation? So I'm going to work that out first. Would you need to use a loop maybe? What variables would you need to keep track of? And you will also need to be adding or subtracting by 1. So how could you implement that? If you looked at the multiplication challenge one, I did use subtracting by 1 a lot in that. So actually how you would do it is, well, let's break it down. So we've got the first value. If you want to get the first result from that sequence, we need to load the first index term, so 1. So I've called it term, and I've stored it as 1 here. Let me zoom out a bit so you can see the more slide. and I'm adding 4 to it because the actual equation was m plus 4, which I'm sure you've all worked out. So I load the term, which is given the initial value of 1, and I add number 2, which is 4, to it. So essentially this is n plus 4. We always add 4 in our nth term, so store 4 as a variable called, yeah, I just said that. So we also need to define a variable so we know which index term we are inserting into our equation. Okay, looping for more values. So now we need to add 1 to the index term variable before we calculate the next number in our sequence. So to do this, we define a variable called 1, which we add to the index term variable. So you can see down here, I've defined a variable named 1, and I've just stored the value 1 in there. So we use a loop to repeat the previous calculations and output each new number in the sequence. So we're just repeating those steps that we did before to get the first number in order to actually get the next value and the next value and so on. So this code will actually just keep repeating that forever. As you can see, there's an instruction stop program, but when it hits here, it always loops back to the start. So it never actually reaches this stop program yet. But if we wanted to only output the first 5 values, we do want it to stop after it's done the first 5 values, then we need to compare our term variable to a limit. Once our term reaches the same value as the limit, we halt the program. So what that's saying is, if I've outputted the first term in the equation, and the second term, and the third term, once it gets to the 5th one, I want to stop. So I should give it a limit. I give the program a limit, and it should stop once it gets to that. So the limit down here is defined as 6. Once it gets to 6, it shouldn't output the 6th term. It only outputs from 1 to 5. That was an I. Okay, so check if the term and limit are the same. If so, jump to the halt instruction. So here, once we've added 1 to the term and stored it, we take away the limit to see if the term is the same, is equal to the limit. If it is, then we stop. Otherwise, we go back to the start and do it again until the term is the same as the limit. Okay, so given this program, so you should be able to just take this program now, write it out. I want you to try and use this code as a starting point to make the sequence n plus 8. So remember, this one is n plus 4. How would you change it so that it gives you the sequence n plus 8? It's not as difficult as you might think. You only have to change one thing, really. And then once you've done that, I'll need to try and change it to get m minus 7, 2m plus 4, 2m minus 6, 3m plus 8, and 8n minus 3. Okay, I'm not going to actually show you how to do this. You should be able to work out what the sequences should be. And then you're going to keep working on this. You don't have to change too much here. But keep working at it until you get the right answers. So think about it. The term is 1 here because n is just 1n. If I needed to do 2n, then maybe I'd have to add term to itself. I'm doubling term first before I add 4. If I needed to do 3n, I'd need the term to be 3 times what it is. I need to add it to itself twice to get 3 terms, and 8n, and so on. So have a go, see if you can manage it. I'm not going to show how to do these tasks because they are difficult and it would take me quite a long time to explain and work it out, to be honest, myself. But these will be available to you if you really want to try them. This one took me over an hour to work out myself. It is a very difficult task. Okay, have a go at it. Actually, you know what? I will show you how to do 2n plus 4. That hopefully will give you an idea how you do the rest. So this is the code you've got so far. If I want to change this so it becomes 2n plus 4, the term is basically n. I've got 1. If I add term to it, then I'm adding 1 to 1, it becomes 2. So that is now 2n. And it was 2n plus 4. This was actually n plus 4, so it doesn't take that much to change. That's all you need to do. So instead of giving me n plus 4, which is 5, 6, 7, 8, 9, it should give me 2n plus 4. Which is 6, 8, 10, 12, and 14. Okay, so the amount of n's is basically you just add terms at the start. If I wanted 3, I just add another term. You guys try and figure out the rest. I can use too much help now. Okay, and that's all from Little Man Computer. Hopefully you've understood the explanations. And if you enjoy them, there's a game on Steam that you can get called Human Resource Machine. It's definitely worth checking out because that's where I got most of these tasks from when I made this workshop.